Welcome to an exciting paper discussion session for the physics JEE test. Here we have got questions on motion in a straight line, various tricky questions. Many questions may seem challenging. Of course, it's the first test. So grab your seat belts and you can join me on the ride to understand motion in a straight line better. So the very first question is a great opportunity for you to enhance your understanding in graphs of motion in a straight line. The challenge here is twofold. The very first question, let me describe the physics of this. There is a ball which is thrown from a height of h, and the height h is measured from the ground, of course, and it is dropped. So the initial speed is 0. The ball, as it is dropped, as I trace its journey forward in time, of course, it will gain speed, it will fall on the ground. After hitting the ground, the second phase of journey begins where it bounces back to a height of d by 2. So, yeah, any tennis ball, other ball, or any golf ball, whatever ball you bounce on the floor, it will definitely raise up to some height. That height would be d by 2. This should be d, sorry. So this will be d by 2. So now we are in the second phase of the drop thing. This, after hitting the ground, will raise to half the original height from which it was dropped. So what would be its velocity at this point? It reaches to a maximum distance of d by 2. So at this point, its velocity is 0. So from the graphs, I should see what all satisfies the following condition. Very first condition is at a height d, velocity should be 0, and a height of d by 2, velocity should be 0. So there should be 2 points at which velocity is 0. One is d, other is d by 2. One is d, other is d by 2. One is d, other is d by 2. The other one is d by 2. Unfortunately, all the four options satisfy this condition. The rightmost point is a d, the left one is d by 2. That is to be understood. Now, how can I eliminate further options? Well, if I know the sign conventions, anything coming down, velocity is negative, and anything pointing up, velocity is positive. So in the first phase, in the D wala phase, it is gaining speed and therefore velocity is becoming more and more negative. Where when it is falling, it's falling, velocity is becoming more and more negative because it is gaining speed, it is accelerating. So it starts from D, velocity should be going downhill, negative. Reason, anything pointing down is positive. So A satisfies, C satisfies, B absolutely doesn't satisfy because at h equal to d, it is showing a weird journey. Both arrows are pointing the same way. At h equal to d, again, velocity is becoming more and more negative. So A, C, D, one of these might be the right choices. How can I further eliminate? Well, in the second phase, in the second phase, the ball is climbing up. So velocity should be positive. Velocity should be positive. Not only that, it should become less and less. It should start as positive, but as it increases the height, it should become less and less positive. Okay, so it is positive over here. As it reaches a d by 2, it should become less and less positive because it is reaching a stop. So at d by 2, velocity is 0, it has become less and less positive. This seems correct. But this one says from d by 2 again, velocity is negative. Velocity can't be negative because our ball is actually going up. So d is ruled out. What about c? C also satisfies the above condition. So should it be a curve or should it be a straight line? Here is where we need to give a thought about the third equation of kinematics. V square is equal to U square plus 2AS, right? Anything in free fall, any object in free fall satisfies this equation. So velocity ka square always depends on the displacement or the height, right? So it is never ever v proportional to s. It is never this. in a uniform acceleration case. Square of velocity depends on position or displacement. So it cannot be a linear relation between velocity and displacement since v is not proportional to s, v squared is. So I would confidently tick option A as the answer. Very tricky one to interpret the graph. So we take the help of sign conventions, initial conditions. The whole journey of the ball is divided into two phases. One, the descending phase of the ball. One, the descending phase of the ball. Other one is the ascending phase of the ball. And descending phase velocity should become more and more negative, whereas in the ascending phase, it will become less and less positive. It should start as positive, but as it reaches a d by 2, it should become less and less, reaching 0 over here. That is possible in a non-linear way only in the first graph, hence the first one is the answer. One of the very tricky question, unless you visualize the ball bouncing from the floor, gaining half the height, the sign conventions, you cannot solve this question. So these are the prerequisites. Question number 2. The velocity displacement graph of a particle moving in a straight line is shown. Velocity, displacement, and again graphs. They're asking acceleration displacement. Is there any relation which satisfies or which relates velocity, displacement, and acceleration in a single line? V, X, and A. The equation should have all these three. That is the hint. So that would be nothing but A equal to V dV by dx. A equal to V dV by dx, right? All right. Then this is a calculation. This is a calculus relation. How can I make my job easier without having to solve such equations? Have a look carefully. As x is increasing, velocity is decreasing. Velocity will decrease only if acceleration is negative. What is one such example? You throw a ball upwards. As the ball is climbing up, what would happen to the speed? The velocity of speed and velocity they would decrease. Reason, acceleration is negative g downwards. So whenever velocity here is negative, it is steadily decreasing. It means as I increase x, acceleration should become negative. So which of the options are in the positive region? Only this option is positive. This is hence not the correct answer. Acceleration cannot be positive. If it was positive, the speed would go up or velocity would be, increasing. What about D? D is also highly improbable because it shows acceleration should be a constant. We can rule out this from this relation. Why? This is a straight line, isn't it? Which means the change in velocity, the change in the y coordinate by change in the x coordinate is always a constant. In other words, the slope is always a constant. You should remember this thing, all right? You focus on this small triangle over there. You take tan theta anywhere on this line, the change in velocity to the change in x is always a constant. So dv by dx from this graph is a constant. If dv by dx is a constant, as you can see, velocity is reducing, velocity is changing. Definitely, acceleration is not a constant. It should also change. dv by dx is a constant due to the graph. V is changing with respect to distance. Therefore, acceleration should not be a constant. Therefore, even D option is eliminated. Now, between A and C. Okay, between A and C. What can be the right thing? Because in both cases, acceleration is negative. In the first case, as x is increasing, acceleration is increasing. Though it starts as negative, as I increase x, acceleration is becoming more and more. But here, though initially it is negative, as I increase x, acceleration is becoming more and more negative. Now, how to, reconcile A and C, between A and C, how to choose? Easy one. dV by dx here, dV by dx is a negative quantity. Why is it a negative quantity? Because the velocity is decreasing with respect to x. So dV is nothing but the change in velocity. It is always negative. If I increase x, speed is decreasing, velocity is decreasing. So dV by dx is always a negative. No? So I can say A equal to minus kV, where minus k is some negative constant. And you should observe, as x is increasing, v is decreasing. So what is happening to acceleration? Acceleration is because initially it was negative. Nevertheless, since v value is decreasing, it is becoming more and more positive. If you don't believe me, you can put values. So how can we put values? A equal to minus kV. So I will put k as 1, say. A equal to minus v. You see, initially let the v value be maximum. Let's say 10. Now, as x is increasing, let's say it came over here where v value is 5. So at a later instant of time, it is minus 5. Initially, acceleration is minus 10. Now it is minus 5. So if you are a good fan of number lines, you would know that. You know that minus 5 is greater than minus 10. So as the distance is increasing, acceleration of the particle should increase and not decrease. But C graph is showing as the position of the particle is increasing, acceleration is becoming more and more in a negative sense. But I know that it's not becoming more and more negative, it's becoming more and more positive. Proof is over here. A equal to minus kV. So A equal to minus 10 initially, A equal to minus 5 later, A equal to minus 3 later. You see, the numbers are actually increasing. Number line. Magnitudes may decrease, but in a number line, minus 5 is greater than minus 10, minus 3 is greater than minus 5. So obviously A should be the right choice for this. See, I have not invoked any integration and put you in a hot soup of straight line equations and stuff. It is only two relations. If velocity is decreasing, acceleration should be negative. And how can I relate acceleration, velocity, and position? A equal to v dv by dx. If a graph is a straight line, then the change, this graph is a straight, vx graph is a straight line. So dv by dx should be always constant. That is how I define a straight line. Now, dv by dx should be a constant, positive or negative, negative constant, because velocity is reducing as x is increasing. With the help of this funda and a number line concept, we realize that as x is increasing, acceleration should become less and less negative. That is possible only in A. So 2 goes with A. No much integration needed. It may take you some time to understand what is going on, but with again, you can listen to this at your convenience. So, yeah, you can have this. You can carry forth this lesson with you. That is second question. Now the third one. Third one is a relative velocity concept. What is happening is there is an edge of a cliff. How can I draw a cliff? A cliff can be drawn like this, some mountain peak. Now it is two stones are thrown, one up, the other down. Okay. So what might happen is they're asking how would their relative position vary with respect to each other? Relative position of what? So instead of a cliff, if I imagine just one tall building and one goes up, the other goes down. One goes, the one which is thrown up is of 10 meter per second. The one which is thrown down is of 40 meter per second. Which will reach the ground first? Question. Which will reach the ground first? That you should answer. So you see, this is thrown very fast down, but this is thrown up. So obviously the second stone will reach the ground first. I hope this is clear. The second one will reach the ground first. What would happen to the first one? The first one will raise to some height. Okay. Then again, it will drop down. Later on, it will start reaching the ground. Okay, so that's settled. The second stone reaches the ground first. They're asking variation of relative velocity of the second stone with respect to the first. So the second stone is on ground. Okay, by the second stone is on the ground while the first one is still moving in air. You see, in A, B, C, D option, till 8 seconds, all the graph represent straight lines. The concept here is xt graph, the slope of xt graph gives you velocity. And if xt graph is a straight line, I would say velocity is constant because slope of a straight line is constant and therefore acceleration is zero. The same concept holds good even for relative position and time. The slope of this would give relative velocity. And if relative velocity, okay, is a constant, it would mean relative acceleration is zero. What is the relative acceleration of the two stones? Both stones, while they are in air, at 8 seconds while they are in air, both have acceleration of g downwards. Therefore, relative acceleration of the stones is zero till one of them reaches the ground. So that is why these graphs are straight lines. Reason, slope, the xt graph gives you velocity. Here, relative velocity is a constant because relative acceleration is zero. Fine. Now, once the second stone reaches the ground, how will the first stone see it? How will the first stone see it? Now you become the first stone. Okay. How will you see it? You will see as if the second stone is coming towards you and it is picking up speed. Reason, you are coming fast down, but whereas this stone is, it is actually at rest, but you are seeing as if it is coming towards you very fast. So the velocity of the second stone, of the second stone with respect to the first, okay, is positive and it is increasing. Velocity of the first with the of the first one with the second is positive, right? So why? Because the second stone is climbing up. The second stone is climbing up. Then velocity sign should be positive and it is increasing with time. Between, obviously C is eliminated, D is eliminated. Between A and B, how would the curve look? Is it like that or is it like this? You see, it should be, you know, becoming more and more positive. It should pick up speed. If it's picking up speed, slopes should be increasing with respect to time. Can you see the slopes should be increasing with respect to time? If I plot the tangents here, slopes won't increase with time. Rather, slopes would decrease with time. The line would sleep. The tangents would sleep as time passes by, but here tangents would try to, stand up. So definitely slope is increasing over here, slope is decreasing over there. So I would go with option A, which says relative velocity of the second stone with respect to the first. Speed should be increasing, so it should be A. Okay. So that is about it. Till 8 seconds, both of them have relative velocity constant, therefore a straight line. But after one of the stone hits the ground, the velocity changes with respect to time. It is accelerated. It's no longer a constant because The one of the stones becomes fixed. Other sees as if it's speeding up and up more and more because it is accelerating. Okay. So this is how you approach the third question. Now, going on to the sixth question. The sixth question is VT graph has been asked. The VT graph is given. They're asking the difference between the distance traveled by the car and the scooter in the 15 seconds. I'll tell you the approach. If you have to calculate the difference in distance traveled by the car and the scooter, well, this is the graph of a car, whereas for a scooter, this is it. So how do you find distance? How do you relate a distance to VT? Distance to VT graph can be related as area under the VT graph. So how do I find the difference between the distances? Well, I will first calculate the area covered, area under the VT graph for the car. Then I will calculate area under the VT graph for the scooter. For the scooter, you remember to include this area, do not omit it. So this is the one in colored, multicolored is the scooter one. The car one is the triangle. I subtract the two areas. If I subtract the two areas, I get the distance. If I look at the options, I see 112.5, 112.5. I think there's a typo over there. 112.5 would be right. So most probably it should be between C and D because examiner usually gives the right choices multiple times to confuse. So the approach is this: you calculate the area, you subtract them, and the time at which the car will catch up with the scooter. Wow. Time at which the car will catch up with the scooter. So how can I find the time at which the car will catch up with the scooter? Easy. What is that? The trick is if the car and scooter catches up with each other, then both of them have the same displacement. And displacement that would mean area under the VT graph. See, here both car and a scooter, they are having a positive velocity, so both distance and displacement becomes identical. So displacement means area under the VT graph. If the car and scooter has to catch up with each other, then at that particular time, both should have same displacement. Okay. So now you calculate. Obviously, over, I mean, in 15 seconds, you calculate the area, and at 15 seconds, you calculate this area. Definitely, there will be a difference in the distance. So it cannot be any time lesser than 15, it should be greater than 15. The time at which they will catch up. The time at which if I have to draw a VT graph for the situation, it is like this. Okay. Till 15, both of them have a distance between them. But let us say there is a time t. Okay. At time t, they will catch up. Then at time t, this area, the area of the scooter VT, should be equal to the area of the car. Scooter VT graph area should be equal to car VT graph area. The point of time that happens, that is the time at which the car will catch up with the scooter. Both of them should have the same displacement at the same time. That would happen if the areas covered respectively are the same. So you can calculate the expression for the area, put the value of t, you'll get the value of t. You can eliminate also. It can't be 15, it can't be 10, either it should be 25 or 22.5. As I can see it, most likely it should be 22.5 because 112.5 is repeated two times in the option. So that has more chance of being right. So that must be C must be the right answer. If you are a JEE aspirant, your first guess would be C. Cool. That is the concept over there. Now, seventh question. In the seventh question, which graph corresponds to an object moving with a constant negative acceleration and a positive velocity? Okay. If it is a constant negative acceleration, how would the VT time, I mean velocity time graph look? It would obviously be a straight line. because slope of Vt gives acceleration. If slope is constant, the graph should be straight. So first one is eliminated. No, it's not that. B, no, because Vt graph has to be a straight line. How will velocity distance vary if acceleration is negative? Okay, acceleration is negative. Uh, uh, the velocity is positive given. Velocity is positive, acceleration is negative. See, just like a vehicle on brakes. If you have a vehicle which is put on brakes, velocity is now decreased, right? So it is a scenario. So velocity should decrease with the distance. So whether would it decrease like D or would it decrease like C is the question. So how to resolve it? For resolving it, we take the result of V square equal to U square plus 2AS. Okay. In both cases, the acceleration is negative, right? So, and velocity is plotted on the y-axis. Velocity is plotted on the y-axis. Some constant, U square is some constant c, let us say, and s is nothing but the distance. Acceleration is negative, so some number kx like that. Which mathematical curve is y square equal to some constant minus kx? Here is where the graphing knowledge would be extremely coming in handy. So what is that? This graph y square equal to c minus kx is this kind of a parabola, whereas y square equal to c plus kx is this kind of a parabola. The only closest option you can see is this kind of a parabola, which is there's a mathematical way of dealing with it. But how to, how can I approach in any other way rather than doing this? We can have A equal to V dV by dx for our reference. Another relation, acceleration, velocity, and position. dV by dx is nothing but the slope of velocity position curve, dV by dx. I have been told that acceleration is negative in the question, but velocity is positive. It means dV by dx graph has to, dV by dx has to be negative. The quantity has to be negative. And not only that, velocity is decreasing. To maintain acceleration at a constant value, the slope dV by dx should increase. Key insight from A equal to V dV by dx. Acceleration is constant. V dV by dx may velocity is decreasing, we know, because speed is decreasing, velocity is decreasing. To keep acceleration constant, dV by dx has to increase. In which of the option between C and D, in which of the option between C and D is the uh, you know the dV by dx actually increasing? If I draw slopes, I can say dV by dx is increasing over here. It was sleeping initially, it is now standing. But here dV by dx, as x increases, slopes are becoming increasingly lesser and lesser. So D cannot be the choice, C is the choice. With this concept itself, you know, the true physics enthusiast approach this. But y square equal to c minus kx and stuff, it is for the mathematically inclined. Only if you're familiar with the math representations, you can do this. But if you're a true physics person, if you have got the feel of the question, it is a equal to v dv by dx. dv by dx is, it should be negative. Okay, dv by dx should be negative and it should increase with x. Only then velocity being positive, acceleration will be a negative constant. That is the That is how you relate between multiple entities graphically and visualize it over here. That is the answer for seventh one. See each of these questions unravel multiple concepts. Now, question number 8. In a car race on a straight road, car A takes a time t less than car B at the finish and passes its finishing point with a speed v more than that of the car B. Both cars start from rest and travel with constant acceleration a1 and a2. Then what is v? You may think of substituting, but unfortunately, the variables are too many, and you may not really end up with the correct substitution to do, for to crack this. So, what is a right substitution? Well, the right substitution is this. I mean, right approach. Right approach should be something like a VT graph. Yes, a VT graph. How would a VT graph? Distance acceleration, or the only graph which will help with distance acceleration is VT. Let's see. A car A takes time t and passes finishing point with speed v more than that of car B. Okay, so I will draw VT graph for A first. Let this be VT graph for A. It starts from rest and it goes till the finishing point. What would be VT graph for B? Hmm. VT graph for B, it also started from rest and it has a speed v lesser than A. It has a speed v lesser than A. Okay. So this is VT graph of B because its acceleration will obviously be lesser than that of A. The slope of B should be less than slope of A. Why would that be? Because the slope of VT graphs gives acceleration, and since A has more accelerations, it completes the race quickly with more speed than B. The slope of A should be more, slope of B should be less. Okay, what further awaits us? Let's complete the triangles. What does area under VT graph give? Displacement. Displacement of both car A and car B is same. Displacement of car A and car B is same because they both travel the same distance and same starting point, same finishing point. And what else is given? Well, if I draw this, this is nothing but the difference in their speeds, which is v, and this is nothing but the difference in their times t. B took t time more than A. A had more speed v compared to B. Okay, and since displacement is same, I can say area of VT graph of A should be equal to area of VT graph of B. Graphical solution advised because you can visualize how this is happening. With this information, they're asking what is V. Not only that, we have also been given the value of the slopes. Slope, let's say theta 1, slope theta 2. Have been told that tan theta 1 is equal to A1 and tan theta 2 equal to A2. VT. Cool. So with this information, how would I tackle and get the answer, especially V? I need this. The areas are the same, and I know the slopes. We should arrive at an algebraic relation relating the good. So let's see. And I have given you the approach. Try a VT graph for this. Algebraically also you can arrive at the answer, but try a VT graph for this and see how much sense can you make for this. So that was question number 8. And what about question number 10? Question number 10 is a usual uh, a frequently asked question. One car moving on a straight road covers one third of the distance with 20 kilometer per hour and the rest with 60 kilometer per hour. What is the average speed? All right, one third of the distance, correct? So let the total distance be 3 kilometers because one third is asked, so I can conveniently calculate one third of 3 kilometers. So one third of 3 kilometers is 1 kilometer. The rest it would be 2 kilometers. In 1 kilometer, it traveled with 20 kilometer per hour with a speed 20 kilometer per hour. And whereas the 2 kilometer one, it traveled with 60 kilometer per hour. Cool. How will you calculate the average speed? Average speed, V average is given by total distance by total time. So 3 kilometers by total time taken. Total time taken is sum of the individual times. Time taken to complete 1 kilometer plus time taken to complete 2 kilometers. So what is the time taken to complete 1 kilometer? This time is distance by speed. So 1 by 20 plus 2 by 60. You calculate this fraction and you will have the answer. Wherever you have one third, three fifths, four fifths, assume a distance which cancels out with the fraction. If it is one third, put 3 kilometers over there. Okay. So that is about the 10th question. And what about the 11th one now? 11th one, a particle is moving with uniform acceleration along a straight line. Velocities at A and B are respectively 7 and 17. If M is a midpoint of AB, what is the ratio T1 equal, T1 by T2 is equal to? Here, I recommend you to sketch a VT graph and try it. I will highlight the algebraic one. Let's do it in turns. You do algebraic, I'll do graphical, and I'll do algebraic, you do the graphical, so that we'll have a hang of both the approaches. So the thing is, there is a point A and B. Point A has 17 meter per second speed, an entity, and the same entity when it comes to B, it has 7, 7 meter per second and 17 meter per second. Okay. And there is a midpoint C, right? The time taken to go from A to C is T1. The time taken to go from C to B is T2. What is the value of T1 is to T2 is being asked. Good. So how do we find first T1 is to T2 ratio? Let this entire distance be, say, X. How can I relate 17, 7, and X? They are going with a uniform acceleration. Remember, uniform acceleration means I can definitely use V square equal to U square plus 2AS, and that is where the key trigger come from. V square equal to U square plus 2AS. Sign conventions. So V is 17, U is 7, and the distance is X. So let's put it. So 289, 17 square equal to 49, 7 square plus 2AX. Okay. But straightforward, you can put this. But even then, you may not be able to find the time relations. So how will you involve time here? Let's see how we can involve time. Now, what is the velocity at C? Let the velocity of C, no, let the velocity at C be V. So I can say between the journey from A to C, V square equal to 49 plus 2AX by 2. Cool. And what about journey from C to B? Now B is final, V is initial. So it would be 289 equal to V square plus 2AX by 2. Whoa, this is looking complicated and deadly. Can we make sense of this somehow, right? There is a way where if I have to bring in time, a parameter over here, I can say that I can use V equal to U plus AT over here once, which is V equal to 7 plus AT1. I can use V equal to U plus AT here over twice, which is 17 equal to V plus AT2. Now somewhere I can make T1 and T2 enter this scheme of things because I don't really need V over there, right? So this is the machinery of the equations given to you. The machinery of the equations is I can put positions. Positions would come in as x and x by 2. Times can be put as v equal to u plus at once for this and v equal to u plus at the other time for this. Okay. Uh, but you may feel it is very tedious. There is, of course, an easier way to handle, which shall come in the one of the future GOATs video, which we are making, the GOAT series. A very simpler approach, but this is the standard one. Wherever you go, you shall find this approach where v square to u square plus 2as and v equal to u plus at both are used together. That would be question number 11. Now, question number 12 again. What would be the approach for question number 10? Okay. So, well, if you have thrown stones many places at many moving things, you'll definitely have a feel of the 12th question. There is a truck. The truck is moving underneath a building. Cool. And the question is, at the instant this is dropped, this is also moving with some velocity and acceleration. What should be the length of the truck such that whatever is thrown just misses the truck? The truck is moving in this direction. The thing is thrown downwards. That is the 12th question. The height is given as 20 meters. Okay, and acceleration is 1 meter per second square and velocity of the truck is 2 meter per second. So at this particular instant, the front end of the truck has u equal to 2 meter per second. Acceleration is constant 1 meter per second square, whereas the initial velocity of the stone is 0. The truck will now imagine me pulling the truck to your left. When will the stone just miss the truck? When when at the time taken by the stone to reach the ground, the truck's, the rear end of the truck, the back end of the truck should have traveled, if the truck has come forward an L distance, that means the stone would have just missed if the stone landed when the front end moved a distance L. Initially, the front end was over here. The front end moved now a distance L so that the stone just landed at the back of the truck. Okay. So what is first step is first find out the time taken by the stone to reach ground. How? S equal to ut plus half at square. And you know the sign conventions. Something, you drop the stone, u is 0, initial point of final point at the bottom. So h will be or s will be equal to minus 20, u is 0, and a is minus 10. From these data, find out the time taken by the stone to reach the ground. By the same time, the truck has to move a distance L. So L should be equal to ut plus half at square. Here also you may use the sign conventions if the need arises because acceleration u and L both will be negative. Anything point towards left is negative. All negatives will cancel. We'll be left with positive only. So L is what you need to find. U is given, a is given, T will find out from the time taken by the stone, and you'll find the length L of the truck such that the stone just misses the truck. Wherever you find just misses, replace the word with just hit. This is what we mean by many a times when we say just missed. It means it just hit. That is the concept behind question number 12. And question number 13. In question number 13, drops of water falling from the roof of a building. Yeah, drops of water is actually the in kinematics one of the very standard varieties of what is the distance between the drops, what is the time difference between the drops reaching the ground. Well, I'll highlight a very general approach for the 13th one. For the 13th one, the stone is for the water drop is making, its way down, and the height of the building is 9 meters. By the time this water drop reaches the first water drop, already there is a fourth water drop ready to leave, which means there are two other water drops which are in air in between. That is the first clue. If the first water drop has already reached the ground, water drop is ready to fall. In between, there should be two more water drops which have fallen at equal time intervals, right? So if I calculate the time taken by the first water drop to reach ground, with what help? With the height help and u equal to 0 help. If I divide that, if I divide the total time, you know, equally by the number of drops, each drops take how much time to, one drop took t seconds. By the time already fourth is in, so if I divide the total time by 4, I may get the time interval between the launch of the water drops, between the falls of the water drops. Total time by 4 is when one after the other the water drops will be falling. How will you calculate the distance between the second and the third at the instant? That is where again you will may have to use S equal to UT plus half AT square. U for the second one is 0. U for the third one is also 0. But you may need to consider the time difference between the second one and the third one. The time difference would be the total time by 4. You put it in the equations and you may arrive at the answer. 13th one. I will not discuss these in much depth because such examples are already there in the module. It is expected that you have done one of these for your tests. So that is question number 13. Question number 14 looks simple, but it is not simple. I will highlight the graphical approach for 14th. A car accelerates from rest at a constant acceleration. So that would mean it is accelerates from rest, reaches maximum velocity, decelerates. Decelerates means its speed is coming down. So I will draw a VT graph, right? And then they're asking what is the maximum speed attained by the car, and the total elapsed time is t. This total time is given as t. Acceleration is alpha, deceleration is beta. How will you find the maximum speed? Isn't the maximum speed the height of this triangle? Vmax. Alpha, acceleration. Acceleration is the slope of VT graph. Acceleration is slope of VT graph. Deceleration is also the slope of VT graph. So what we have is tan theta 1 is alpha, tan theta 2 is beta. Okay. And I need to find Vmax. I need to find the height, this height of the traffic. I have converted the question into an exercise in trigonometry. Again, is there any further clue which can be given. No, there's no further entity, there's no further thing. The data is this much. So it accelerates at alpha, decelerates the beta. I need to find the height of the triangle. How can I find the height of the triangle? Let us take this triangle number one. Vmax by, let us say, the small time, this is T1. Vmax by T1 is the tan of theta 1, tan theta 1 is alpha. Similarly, in triangle number 2 over here, I can say that Vmax by T2, T2 being this time, is beta. All right. So T1 can be written as Vmax by alpha, whereas T2 can be written as Vmax by beta. When I add both of them, I encounter something very special. T1 plus T2 is already given in the question, that is T. And here I can take Vmax common. So I can express Vmax in terms of T, alpha, and this I have, this looks very long when we explain it, but if you are intuitive and catch the VT graph, it is simple. Only trigonometry says that is. That is approach for question number 14. Now, for question number 15. Between two stations, a car accelerates from rest uniformly at first, then moves with constant, and finally retards uniformly to come to rest. If the ratio of the time taken is 1 is to 8 is to 1, and the maximum speed attained is 60 km per hour, what is the average speed over the journey? Okay, so here it is. You should note something. The accelerates uniformly, the time taken is 1. Finally, retards also, the time taken ratio is 1. See, if the time taken, time taken to from rest to go to some speed and from that speed to go to rest again, both times the same, that would only mean in both phases, acceleration is the same. The magnitude of acceleration is the same, which means if the car is accelerating in the first phase with 1 meter per second square, it will retard with minus 1 meter per second square. The magnitude of acceleration is the same. That is the first observation. We will again have a VT graph for the 15th one. VT graphs are the way to go. For the 15th one, VT graph, how would it look like? It is starts from rest, accelerates, remains constant for some time. With the same slope, it comes back. Okay. You need to find the average speed for this average speed. And the ratio of the time taken is given, maximum speed is given. This speed, the maximum that is attained in the journey, this is given as 60 km per hour. And T1, T2, T3, if you say, T1 is to T2 is to T3 is to 1 is to 8 is to 1. Information field. They're asking what is average speed. Average speed is the total area, the area by the total time, which is T1 plus T2 plus T3. This is how you will represent the graph in VC. Okay. So let's see. T1 is to T2 is to T3, all are given. We know acceleration is also same, right? What further picture can I draw from this? Well, here acceleration is same. So I can say this angle tan of this angle is theta, and even this angle should be theta because both accelerations are same, so slopes should be same. Tan thetas are the same. Okay, fine. Is there anything more I can do? Let's straight away begin with the area part. What is the area? The first area. The first area is half into 60 into T1, right? Area 1. What is area 2? That would be T2 into 60. What is area 3? That would be T3 half into T3 into 60. I will add all these areas and get the total area. Okay. That and then something more is also that we know that T1 should be equal to T3. T1 should be equal to T3. Reason being, equal times are taken. So T1 should be equal to T3. So much information. Try to make sense of this. Areas have given. T1 is to T2 is to T3, 1 is to 8 is to 1. That information is given. Using your high school mathematics, try to, say something about these. Let us say T1 is K, T2 is 8K, and T3 is also K. Yeah. Put these values here. Finally, it will be in all terms of Ks. Add and get the. So this is the very convenient time optimal approach for the 15th question. No need to convert to meter per second at all. 60th one. Oh, sorry, 16th one. 16th one, a train and a bird. Hmm, train and a bird. For the train and a bird one, we do this. Many people have fallen prey to this. The train here is going with some speed V1, this also with V1. Then there is this crazy bird in between. I have drawn a fish. Oh, some bird in between. This bird is constantly going back and forth between the trains. I don't know why it is getting so crazy, but yeah, that is the thing. The bird is flying at a constant speed of 60 kilometer per hour. It will hit one train and get back. It will hit this train, get back. Okay, but these trains are approaching each other. They're asking what is the total distance traveled by the bird. We know that distance is nothing but speed into time. Speed of the bird is given as 60 kilometer per hour. 60 kilometer per hour is into, I don't need to do meter per second conversion because all the options are in kilometers. 60 kilometer per hour. And what is the time taken? At what time will these two trains meet? Initially, the two trains, if you have a look at the 14th, at the 16th one, the two trains are 90 kilometer apart. 90 kilometer apart. Let's say that let's say the trains are 90 kilometer apart. L. At what time will these meet? Here, two objects are introduced, so we use relative velocity. What is relative velocity of train 1 with respect to train 2? If I assume, if imagine you are on this train, you will see this train coming faster towards you. It already had some speed. Your speed also will be added up. So it will be 2v1. And what is the distance it will travel to hit you? It will travel, you know, distance would be L. So what is the time taken by the second train to hit you? Time taken would be distance by speed, which is L by 2v1. In this time, how much distance would this poor damn bird have flown? It would be distance traveled by the bird is speed of the bird v2 into time taken, which is L by 2v1. Substitute speed of the bird, substitute speed of the train, substitute the distance between the trains, kilometers per hours and kilometers, we will have the answer. But the key is a relative velocity. And this is a golden thing. They're not asking displacement and stuff. Distance doesn't have to do anything with direction. So distance is simply speed of the bird into time taken by the two trains to collide, because only till then the bird shall be alive. So how will you find the time taken by the trains to collide? Relative velocity, you assume that you are fixed. So you shall see the train coming towards you with twice your speed, because your speed and that train speed both are same, twice the speed, and it will have to travel L distance. So what time it will take to hit you? The distance by speed to V1. An interesting question. The 16th one. Right. 17th question. The 17th one is a displacement x related to time t. Find the displacement when its velocity is zero. A very familiar form. Whenever quantities are related like t in the roots, whenever you see roots coming in the picture, t equal to root x plus 3, right? Is there a scope of making everything quadratic, root t equal to root x plus 3? Yes, I can see that. What I can do is root x is t minus 3, x is t minus 3 the whole square, which would be t square minus 6t plus 9. Now they're asking what is the displacement of the particle when its velocity is zero. Okay. I will compare this. I will compare this equation with x equal to ut plus x equal to x equal to ut plus half at square plus x naught, where x naught is the initial position of the particle. The initial position of the particle is 9. Initial velocity would be coefficient of t, which is 6. Here it was 9, right? Initially it was at 9. And now initial velocity is minus 6. So it is going towards this side with u equal to minus 6. And what is its acceleration? What is the coefficient of t square here? It is 1. 1 is equal to half a. So a should be equal to 2. A should be equal to 2. When is its velocity 0? V equal to u plus at. V is 0. U is minus 6. A is 2. So from these, I get t as 3 seconds. At t equal to 3 seconds, what is the position of the particle? At t equal to 3 seconds, the position of the particle is x is equal to 9 minus 18 plus 9, 0. The position of the particle is 9 minus 18 plus 9, which is 18 minus 18, 0. So at t equal to 3 seconds, this guy is over here. The question is, what is the displacement of the particle when its velocity is 0? Now, how will you get the displacement of the particle? Well, displacement is initially it was over here, right? And at t equal to 3 seconds, its velocity became 0. So at t equal to 3 seconds, it is at the origin. So from here to the origin, initial position to final position, what is it that is the distance? That would be the displacement. Okay, t square minus 6t plus 9, and then compare it with s equal to ut plus half at square. Half a should be equal to 1, so a should be equal to 2. From there on, it is the graphical approach. Okay, you should actually feel the particle. Initially, it was at 9 going towards left because u is -6, right? And it is, at what time would its velocity will be 0 at t equal to 3. At t equal to 3, where was it? It was at the origin. So what is the distance between them? That is the catch. The distance between initial and final position is the displacement. So that would be question number 17. Question number 18. Question number 18 is a standard result that is being used in many places. T equal to root T1, T2. Reason being, there is the time taken by a stone which is thrown up with you to come down again is T1. From the same building, if I throw a stone vertically down with the same speed, it will land in T2. What would be the time taken by the particle if it is just dropped to go the same distance? T equal to question mark. Right? All in all three things, the common factor is H, H, and the result says T should be equal to root of T1 and T2. Well, is there any way where I can make this easier? I can. I can by assuming that u equal to 0 here also, here also. If u is equal to 0 in these two cases, then the T1 equal to T2 because I'm dropping here also, and both of them should be equal to the T which I am finding. So if I substitute T1 equal to T2 in the options, I should get the time. Here, T1 equal to T2, if I substitute, I'll get 1, so that's not correct. T1 equal to T2, if I substitute, I get 0, not correct. T1 equal to T2, I'll substitute. Do I get T1? Yes, I get T1. T1 equal to T2, I substitute. So, square root of T1 square, again T equal to T1, this is also right. Now what will I do? Is it T1 plus T2 by 2 or root of T1, T2? Here is where intuition can guide you. You know that h is equal to half at square. Since displacements is the same in all the three, h, h, and h, t squared should be the same in all the cases. Somewhere squares are entering the picture. Here there is only a linear relationship between the two. It's not correct. So it should be C, where a square root is entering the picture. Very time optimal way to arrive at the answer. That is question number 8. Now question number 19. In question number 19, there is an AT graph. I have to sketch the corresponding VT graph for this. How will I sketch the corresponding VT graph? Is AT, acceleration is increasing with respect to time. But here I'm being shown that velocity is being a constant. Can you see a contrast here? So B is ruled out. Acceleration initially is itself, it starts from 0, but it is increasing. Velocity cannot be 0 for so long. At t equal to 0, acceleration is there. At t equal to 0.001 or itself, velocity will be there. Here it is being shown that velocity is 0 for a long time. Hence, this can't be right. What about D? Look, as I keep drawing slopes of VT graph, slope of VT graphs gives acceleration. Here I am seeing that slope is getting decreased as I draw tangents. Slope decreasing means acceleration is getting decreased. Acceleration is becoming less and less if according to D. But according to the graph, acceleration is actually increasing. So even D cannot be the answer. It should be A. By use of elimination and graphical analysis, we come to the conclusion that 19th one goes with no. Question number 20. In question number 20, if the taxis leave station X for station Y every 10 minutes, well, it is less of a motion in straight line question, more of a mental ability question. I will leave you with some, basic approach which you need over here. Assume that a car started from X and it went to Y. Okay, now it is at Y. The car is at Y. How long did it take? It took 2 hours. Fine. Let this be in your mind. In these 2 hours, how many cars are on the road? In these 2 hours, how many cars are on the road? So in the 2 hours, every 10 minutes, one car, right? So in the 2 hours, how many cars? One car went all the way. Now I'm calculating like this. Okay. Hey, hint number one. Hint number two, which is, uh, I mean, not of aptitude level, but I want to make it more physics level, is for question number 20, the car wala thing, I will use relative velocity. Some cool. X and Y. When will the first cars meet? Find that out. At what time will the first car, the first that come from X and Y will meet? At what time will they, what time will they, right? So it is, the car from X takes 2 hours to go to Y, and the car from Y takes 2 hours to go to X. So from symmetry, I can say that both cars meet midway at 1 hour. Okay. In this 1 hour, how many cars have come from X and how many cars have come from Y in 1 hour? Well, 10 minutes, one car. So 60 minutes, how many cars? Six cars. Six cars have already been behind this car, and six cars are behind that car. So, so how many more cars will this meet? This will meet six. That will meet six. Okay. Because already it was there. But, you know, not only the cars are not only on the ground already, but from Y also they are coming still, because this car will take 1 more hour to reach Y. In that 1 more hour, how many are going to come? Already there are six cars. In 1 more hour, by this 1 more hour, this car reaches there. Just, just five cars would have come. Just five cars would have come from Y. Right? So totally you make an estimate of how many cars each of them is meeting using relative velocity. I use relative velocity only for one purpose. At what time will the first two cars meet? Then I calculated how many cars will be behind this car already, how many cars will be behind this car already. Then as this car is traveling, how many new cars will be coming from the back? If I keep a track of all these, I'll be able to arrive at the final answer. That is question number 20, mental aptitude, but more physics would be required in the second one. Question number 23. Distance covered by a particle in 1D motion varies as t equal to x square equal to at square plus 2bt, blah, blah, blah. X. How does acceleration depend on x? The holy flow chart. X, v, A. How will I get acceleration if position and time is given? I'll have to differentiate two times. But it is x squared, mind you, not x. Trouble. Here's a clever substitution. Put A equal to C equal to 0 and put B as half. Over here. When you do that, you get x squared is equal to t. So x is equal to root t. What would be velocity? Using the golden rule, dx by dt, velocity would be 1 by 2 root t. What would be acceleration? Acceleration would be 1 by 2 root t, t power minus half. So it will be t power minus 3 by 2 would come in the powers. Acceleration I would find out is proportional to t power minus half ka cube. But what is t power minus half or t power uh, half? What would be that? That is itself x, right? So what is that exponent that is, looming large at you? What is that integer that's coming large at you? That is the integer 3. So n value should be equal to 3. Okay. Now, question number 24. What is the concept for question number 24? They're asking the position of the particle at t equal to 5 seconds, not at t equal to 8 seconds, as most of you might calculate at t equal to 5 only. So I calculate this area by using anything I like. For example, I can say that this is a triangle and this is a rectangle and that is also one rectangle. So combination of a triangle and two rectangles, it will give me the area, and that would be the position of the particle at t equal to 5 seconds. How? Area under VT graph always gives you displacement. Question number 25. Okay. If a body loses half of its velocity on penetrating 3 centimeter in a wooden block, how much more it will penetrate? Well, a CET concept again revisited. So if if a bullet hits with you, it will loses half of its velocity in 3 centimeters. At what, you know, how much more distance will it take before it comes to V equal to 0? This we have tackled in graphical approach. You can look at the CET solutions, but here also I need to emphasize something. It can be done through graphs as well as it can be done through uh, algebraic analysis with the help of V square is equal to U square plus 2AS. For the first journey, V is U by 2, U is U itself, and S is 3 centimeters. For the second journey, V is 0, U is U by 2, and S is X, whereas acceleration is an absolute constant. That's the good part. And that's how you'll arrive at the how much more distance X value. Now, 26th, right? In the 26th question, in the last half a second before hitting the ground, it covers a distance of 19 meters. What is acceleration due to gravity on the surface of that planet? Okay. So 26th one, I will use a graphical approach. Anything going down is negative, G is negative, so the VT graph would look like that. It covers a distance of 19 meters. Distance is the area in half a second. And what is the total displacement as it landed on the ground? The total displacement as it landed on the ground is simply the height of the tower. So what is the total area? The big triangle area. The big triangle area is 100. The shaded black one area is 19. Well, with this, they want you to find what is acceleration. What is acceleration? Acceleration is ratio of the slope of Vt, which is perpendicular by base. Perpendicular by base. Okay. How can we use that? Area of a similar triangle. We should note that the small triangle and the big triangle are similar. Let this time be t. Okay. The big triangle area of big triangle is 100. Area of small triangle is area of the big triangle minus area of the black portion, which is 100 minus 19, 81. When I divide them, 100 by 81, that should be equal to the square of their corresponding side, similar triangles, wala thing, which is t plus half by half. Correct? From here, you find out what is t plus half. So what would be t plus? I will find t plus half itself. I'll take square roots on both sides. So 10 by 9 is t plus half, where this distance upon 1 by 2. So what is this distance? From there, I can make a great deal. What is this distance? T plus half. T plus half is 10 by 9 into 1 by 2, or t plus half is 5 by 9. So I have a triangle. The entire base of the triangle, t plus half, is 5 by 9. The area of the triangle is 100, height of the tower. Can you find what should be the perpendicular thing? Area is 100. Half into base into height. Half into 5 by 9 into P equal to 100. From there you find out the value of P. Then use tan theta is equal to P by 5 by 9. Why would you use tan theta? Because angle, tan of the angle gives acceleration, right? Tan slope is tan theta, and that itself is acceleration. That is the G on the planet. This much can be done with graphs and not algebraic approaches. Algebraic approaches would take a lot of time to solve, and it's very tedious and cumbersome. Similarity always helps to the rescue. It is always at the rescue. Now we shall have a look at the 27th question on a two-lane road. Okay. First, I will, uh, convert all 36s and 54s and kilometers to meters. The situation is there is a car A. A is traveling with 36 into 5 by 18, which is 10 meter per second towards right. Then there is car B on the behind. This distance is 1,000 meters. 54 kilometer per hour. 54 kilometer per hour is 15 meter per second. It's approaching A. Now there's a car C also with a distance of 1,000 meters. It is approaching A itself with 15 meter per second. As I see it, A is definitely having an accident, but they're asking what acceleration, because A and C are sure to collide. What acceleration B should have to just avoid an accident? Well, let us let us see everything from the perspective of A, relative velocity to the rescue. If I am sitting on top of A, how will I see C coming? Well, now C would be coming towards me 25, because opposite directions, velocities add up and the distance is 1,000. And how would B be? there. 15 and 10, so it will be having an initial of 5 meter per second because same direction, velocity subtract, and it will be having some acceleration also. That's the question. And the distance between this is also 1000. The biggest advantage is right now the A is at rest. What is the time taken by C to reach A? C to reach A, 1000 meters, 25 meter per second speed. Time taken is 1000 by 25, which is 40 seconds. So C hits A in 40. In meantime, B wants to avoid accident. So he has to just reach 1000. Initial velocity is 5. Acceleration, I do not know. Distance is 1000. Time taken is 40. So how will you find out A? F equal to ut plus half a distance. And there you have the value. A funny problem. C will definitely, C and A are going to have an accident. B won't. If it somehow just reaches the spot, you know, reaches 1000. Okay. But realistically speaking, if it has to avoid an accident, it has to come to rest at this point. Okay. So that would be a JEE advanced question. But on a mains superficial level, you can do this. That is question number 27. Now, question number 28. Balls being thrown up in succession. Okay. Same logic as water drops. Water drops and balls, rocks, stones thrown up, everything has the same logic. Maximum height of one of the ball is given. The next ball is thrown up when the previous ball is at the maximum height. Well, so 28 is funny, right? Next ball is thrown up when one ball has reached the maximum height. Let this be 1. It's going up. It reached the maximum height, say 5 meters. As it reached the maximum height, another ball is ready to be thrown up. How many balls are thrown each second? Well, what is the time taken for the one ball to reach the maximum height? T is always equal to 2u by g, standard formula. 2 into 5 by 10. That would give you 1 second. In 1 second, the first one goes up. So the next one is thrown at t equal to 1 second only. So how many balls are in air in 1 second? You can imagine. Okay. So the time taken by first ball to reach up is 1. In the meantime, another is ready. So how many balls I can actually manage? The answer is staring you at your face. So that is question number 28. Question number 29, once more, it is a relative velocity concept. We have done this in the classes too, where, police thief, police jeep kind of a situation. The motorbike crosses the turning at a speed of 72. The jeep follows it at a speed of 90, crossing the turning 10 seconds later than the bike. Nobody is accelerating over here. So what is happening? So there is a turning for all practical purposes. This turning is our origin. The culprit reaches there first and then the jeep. After 10 seconds, culprit reaches, the jeep reaches. So obviously the culprit would be ahead by 10 seconds. Speed of the culprit is 72 kilometer per hour. Seconds is given 72 into 5 by 18. I will get 20 meter per second. Speed. Police is just about to, he's over here with 90 kilometer per hour. 90 kilometer per hour is 90 into 5 by 18, which is 25 meter per second. He is the police. right? So the question is, now the police is having a speed at 25 meter per second, but the culprit has already going with 20 and he has spent 10 seconds in going this distance. How much distance is that? 20 into 10, that is 200 meters. Speed into time. So the culprit is ahead of 200 meters from the police. How long will it take or how far it will take should be the question. How far from the turning? So, what is the total distance traveled by the police in order to catch the culprit? How far from the turning is the question asked? Let us do this in relative velocity concept. Let us see this question from the perspective of the policeman. Let the policeman be, you be the police. You will see that s- both velocities are in the same direction. You will see that C is coming towards you with a speed of 5 meter per second. Relative relative speed of the thief with respect to police is 5 meter per second. How much time he will take to come to you? You are at rest because it's relative velocity. So he will take how much time? Time is a distance by speed, which is 40 seconds. So he will take 40 seconds to come to you. So what's the time in which the police will catch the thief? 40 seconds. But that's not it. How far did the police travel in this time? Now, that can't be solved by relative velocity because in relative velocity, we have actually fixed the police. The police is actually moving. No, we have made him fixed. So how would I calculate the distance moved by the police in this time? Distance is equal to speed of police into time taken. That, which is 1 kilometer, 1,000 meters of 1 kilometer is the answer, right? 1 kilometer. So distance traveled by the police before catching thief is 1 kilometer. How did we do this? Relative velocity. Why relative velocity? Whenever there are more than two objects in motion, we use relative velocity. Okay. Then what about the 30th one? 30th one, if you notice, it is very similar to a previous question. A taking T less than car B and passing with V more than car B. A1 and A2 is given. Find B. So if we have solved question number 8 correctly, substitute the values of A1, A2s and T's there, you will get the answer to 30th question. It's a rather a very lengthy paper in motion in 1D. If you aren't thorough with the subtleties involved in relative velocity, VT graphs, AT graphs, then well, it is quite challenging indeed. So that is it, folks, from my side. Thank you very much for your patience. A long video. Hope somewhere it helped. So thank you very much. Take care. Bye bye. Feel physics and do physics.